Not a tough lesson today, just because it's basically the same thing over and over again. Okay? Here's what I did. We want to compare. I'm going to go through the equation first, and then we're going to do male versus female ACT scores. Remember I asked you to do that on the card yesterday? So we'll go through and compare that. Two sample t interval. You're going to want to write this down somewhere in your notes. x1 minus x2, as if it was p1 minus p2, except that we're dealing with quantitative data as opposed to categorical. Categorical is a proportion. 15 out of the 40 women got pregnant. 50 out of the 100 people said yes. That is like a categorical kind of a scenario, yes or no. Whereas this is quantitative. What was your score? Okay, and we're going to find the average male, and we're going to find the average female score. Okay? That creates the center, the x1 minus x2. In other words, what am I centered around when we talk about our interval? Plus or minus t star. If you go back, we'll come back to this, but t star is your degrees of freedom, your confidence level where those two intersect. Okay? Times your standard deviation squared over n1 plus standard deviation of the second one squared over n2. Why are they squared? Why do they square the standard deviations? Yeah, you can't add standard deviations. You have to add variances. Way back a few chapters, right? This goes back to that same scenario. In order to add these, I have to add their variances, and then don't forget to take into account their sample size. Square root of the whole thing. Where is that on your College Board sheet? Here it is, right here. Your standard deviation of the statistic, that's it, right? Except that instead of sigma, it's a t-test, so that's got to be S of 1 and S of 2. So it's on there. It's on your College Board sheet. Just had to figure out what went where. And then this is statistic. That's your x1 minus x2. Critical values, because it's a t-test, that's your t star, etc. Degrees of freedom comes into play when you do it with the t-test. But I have two different samples, so which one do we use? Which one would be more conservative? Use the bigger one or the smaller one? To be further down or further up on the scale? Which one's more conservative, more safe? Further up, right? So in that thinking, degrees of freedom is n minus 1, where n is just simply your smaller of the two samples. It is the smaller of the two samples. That, just take it because that'll put you further up on that t-table. Be sure to spell out the parameter and what x bar and x, you don't need to write that down because that remember. Assumptions, not much change, simple random sample, normal. N1 has to be greater than or equal to 30, N2 has to be greater than or equal to 30. If they're not, then you have to go, is it between 15 and 30? Has some skewness, no outliers. If it's less than 15, it can have no skewness and no outliers. So you have to do your histogram and quickly check. And again, if even one of them is less than 30, you have to test that one specifically and draw the little picture underneath saying it looks like it's pretty normal. Or it's fine. Or a box and whiskers. I like box and whiskers. Independence, replacement for both samples, or you have to test 10 times N1. Is that less than the population? And 10 times N2. Both have to be less than the population. Questions on the equation? At this point, my guess is it's pretty straightforward. This is your center, this is your spread, this is your standard error, this is your margin of error with a t-star included into it. Shape, center, spread, so we need shape. Here's your shape when you're dealing with the normal part. Proving that. Okay, so let's go to the example. Find a 90% confidence interval for the true mean difference between males and females ACT scores for students here at Rosemount High School. Okay, that's what I'm interested in. That's going to be my parameter. Okay, that have taken the test in the last year, let's just say. Parameter, we are interested in the ACT scores of males and females at RHS. X1 for me is going to equal the males, XM. The mean of the second data is the females, their average ACT scores. I'll have to go through and test these, and then we'll go through. First thing I need, though, is X bar for males and females, and I need the standard deviation and the sample size, right? So what we did is, this has already been typed in. It's in Excel. Now, I could have had you do it in your calculator, but I want to show you something with Excel. All right, and I purposely did this so that you could see how to do this if it ever came up in your future college days or high school, but probably college. I have my males listed here and I have my females listed here. What I want to do is find the average and standard deviation of each of those, right? And I know my sample size is, ooh, actually we were off on this one. My sample size is 34, right? Take off the first one. So that should be 34. And for females, it's going to be 32. Both are over the 15, which is really nice, or over the 30, which is really nice. Okay, so here's how you do it on Excel. I go in here, and I highlight a cell. I can go up here to this little summation at the very top, and I can find the average. And it highlights what they think I want the average of. I agree with it. I want that column. I hit return. The class average for males was 25.5. I want to find the average for females. So I go back, hit sum or average. This time it wants it for the 25.5. I go, no, that's not what I want. So I hit the delete. I want it for 27 to 22 for females. Fills it in C2 to C3. I hit enter. Class average was 26.09 for girls. I need the standard deviation. So I go up here to the sum and I go, well, there's no standard deviation in here. So if you hit more functions, up will pop this formula builder. And then you can scroll down. There is a ton of things in here. From date and time to business to engineering to calculus. There's a ton of different equations. So I just went through and found standard deviation, obviously probably under the S's. So I want the standard deviation. And it says for what? And I say yes for that, but no, I don't want this one. So I want, actually, let's delete that. I want it for this area, right? Oops, I think something happened here. Let's do it. Clear this out.
You gotta delete some fields.
I want it for 23 to 22. Hit enter. There's my standard deviation. I want the standard deviation again for females. I'm going to clear that out. I don't want 36. I want it for this whole column. I hit enter. And there's my standard deviation for females. A little easier to see there. So you can do it on Excel. You can do it on your calculators. Okay, I just wanted to show you that because businesses are coming to us now saying students don't understand Excel. Really start to try and show them a little bit more. So every once in a while I throw that out at you. We have our information. I've already got it written down on the sideboard. Right? Yep.
The standard deviation for the males is different than on the computer.
It's 06. Oh, you're right. What do we get? 3.067? I wonder what.
Maybe last time you took the average one.
I thought I got rid of that. Well, we'll just stay with what we got here. Let's change this to 3.07. There we go. Okay, thank you. Catch that. Okay, so now I go back and let's fill in our data. Because now I have the information I need. Parameter, we are interested in the HET scores of males and females at RHS. I've already labeled off what these are. Assumption, simple random sample. Was this a good simple random sample? No, it was all my AP Stats students. So if you go back and look at those scores, there's a lot. There's no 16s, 17s, 18s in there. 19s at all. Okay, so yeah, there's a big difference there. To give you an idea, by the way, Minnesota state average, I believe, or the national average, I believe, is 20.1, if I'm not mistaken, or 18.9. Either way, it's down there. The state average is like 21.1. Rosemount average has been floating around the 23.2 range. It used to be 22.7, and over the last couple of years, now you guys are sitting at about 23 point, which is one of the higher in the state. So just to kind of give you an idea how you guys compare to everyone else. The other thing I thought I'd tell you is when you look at college schools, you have to take what's called an AccuPlacer test. If you go to a state college, Normandale, Mankato, any one of those schools, St. Cloud, Stout, University of Minnesota, Minnesota Duluth, they'll make you take an placer tests. We have had we've had calc students fail the AccuPlacer test. I've had AP Stat students fail the AccuPlacer test. And what that means is then you have to take their basic math course, pay for it, don't get credit for it, and then you pass it and they say, all right, now you can take our regular 101 math course. And then you take that course, pass it, and then you get your math done. And we're like, that AccuPlacer is so not accurate. You have to simplify radicals, you have to simplify or factor things, you have all this stuff that you haven't done for years, and we are way above and beyond, and we've been trying to tell them that. What they told us when we were at our last meeting last week or 2 weeks ago, when you guys had the day off and we went out to Inver Hills, they said, actually tell your counselor that you got a 26 on your ACT, and then you won't have to take the AccuPlacer. So that is new. We had not heard of that before. They said, yes, if you can say that you've gotten a 26 on the ACT, I would guess the math part of it, that you don't have to take the AccuPlacer. And then you can go right into a math that you need. Okay, so don't forget that. Otherwise, that AccuPlacer test is tough. Back to this. I'm not sure how I got off. Simple random sample, approximately normal. Is N1, in this case, N1 for me was males, so I can put a little M there. Was that greater than or equal to 30? Yes, we had 34, which is greater than or equal to 30. N2, which was my females, that was 32. Awesome. We're greater than or equal to 30, so we're okay there. Fantastic. I don't have to do anything else. Independence is 10 times 34 less than the population of Rosemount High School students. Because this is my reference here. That's my population, right? Was there, is 340 less than the population of people that took in the last year the ACT from Rosemount? I would say probably. Okay, especially when you have 500 per class and you're taking your seniors and your juniors combined. Okay, how about for females? 10 times 32 is 320. That's less than the population. We should be okay there as well. All right, let's fill it in. X1, but for me it's X males minus females. That's the way I have it written up. Males was 25.5 minus females, which is 26.09. Plus or minus T star. Ooh, let's stop there a minute. What's my degrees of freedom? What's my smaller sample size? 32. So 32 minus 1. Let's go over here to the table. I don't have a 31, so I'm going to look at row 30. And it was a 90% confidence level. That's this column. This row, where those two intersect, is my T star, so 1.697. 1.697 times the standard deviation of variance for the first one. So we get 3.07 squared over its sample size of 34 plus the variance of the second one, so 3.05 squared over its sample size of 32. Take out your calculators. Help me with this one because I don't want you to have to type this in by hand. Stat test 2 sample T interval. I think it's number 0. It's easier to scroll up than it is to scroll down now. Pooled means combined. But do we have a pooled on this one? Just leave it as what is it? No. Leave it as no right now. And that's a 2 sample T interval, not a proportion interval, right? Pooled, you'll learn later on. Pooled means, are your variances the same? And our standard deviations aren't the same, so you would say no. If they are the exact same, then we have to say pool. It just changes a little bit, but that's all you would have to say.
It's like 90.
90% confidence level. What do you get?
It's not pooled.
Not pooled. My standard deviations are different.
I got the interval of negative 1.848 through 0.6678.
Second on that one? Good. Conclusion, I am 90% confident the true difference in the mean. Yesterday it was the true difference in the proportion, but now we're dealing with an actual number. So we're dealing with the mean ACT scores of males and females. You could change this now that we know females did better than males, supposedly, in terms of our numbers here. females minus males, or you could say females and males, but we're going to make a conclusion here anyways. At RHS are between negative 1.848 and negative and 0.6678 points, with who possibly doing better? With females possibly doing better than males. That way they know that females had a higher score than males. Do we have significant evidence, though? Now that we've been through this, I'm not even sure I can say this part. Do we have significant evidence?
No.
Why not?
Zero false improvement.
Ah. Your null in this case would have been the mean, mu, not x, but mu, because we're going back to population. Mu of males is equal to mu of females, or males minus females is equal to 0. That 0 falls in my interval, so we won't have significant evidence. In fact, I have significant evidence at this point to fail to reject the null, if I was to take a guess. We haven't done a 2-sample t-test. That comes up in 2 days, but you can already see. If I did a 2-sample t-test for this, we wouldn't find evidence. Looks like there's a difference, but it's not significant, which you probably would have guessed to begin with.